Welcome to DSE Physics. Still remember, there are 5 big topics in DSE Physics. In the first term, you have spent some time to study the physics of light, which is under the topic wave. In the second term, you are now going to study heat. In physics, we adopt the flipped classroom teaching method. So you will learn by watching video at home and do your own notes. And when you go to school, you will have more time for classroom activities. You will have more chance to ask questions and discuss with your classmates. And now, would you please prepare yourself a pen? We will start very soon. This is the set of notes which is specially prepared for you. On the inside cover, it explains what flipped classroom is. It tells you how we calculate the CA marks and examination marks, and the hints for getting high marks. So all you have to do is to watch the video before lesson and then finish every single question in your notes, and always try to ask your teacher or discuss with your classmates to solve all the problems in your notes. So what you will learn in the next 10 cycles or so, you can see there are altogether 4 chapters only. Chapter 1 will talk about temperature and thermometer. You will see how thermometer may measure temperature. You may also see the relationship between temperature and particle motion. The second chapter is about internal energy and heat transfer. Simply speaking, it is about energy transfer between objects. Chapter 3 is about calculations. When objects absorb energy, then the temperature increases. So how much the temperature will be increased, then you have to do calculation. You will even know the final temperature when you mix cold water and hot water together. This is about the mixture of substances of different temperatures. And lastly, it is chapter 4. It is about heat conduction. And so here is that, chapter 1. Let's turn to the next page. Here's a cup of coffee. If I ask you, is the coffee hot? What will you do? You may try it, right? You may find it just right, but it may be too hot for me. Because feeling is subjective. A cup of tea will be too cold for somebody, but it may be too hot for somebody else. So in order to compare hotness more objectively, then we have to use temperature. Temperature is an objective measurement of hotness. Well, it is not a problem of you or me. It is just a problem of feeling. So let's take a look at the following examples to illustrate the idea. So in this experiment, there is only you. And you have 2 hands. You put your one hand into hot water. You put your another hand into iced water, which is very cold. So you keep your hands in the water for some time, and then you may move both of your hands into take water. So what will you feel? Your 2 hands will tell you different feelings. The hand that was in ice water will tell you the tap water is quite warm, and the hand which was in hot water will tell you the tap water is quite cold. So why does it happen? Well, it's just because feeling is subjective. So we have to use some objective measurement, and that is temperature. Temperature is an objective measurement so that you may compare hotness. And now pick up a pen and let's finish the checkpoints questions below. So you can see from above that our feeling is not reliable. We should use some kind of objective measurement in order to compare hotness. So what is it? The instrument that we should use is called thermometer. So just because our feeling is not reliable to compare hotness, we should use an objective instrument such as thermometer to measure the temperatures to compare their hotness. And now the second question. There are 2 beakers, A and B, and their temperatures are 40 degrees Celsius and 5 degrees Celsius. Now you put your right hand into beaker A and left hand into beaker B, and then put both ends into beaker C, which is at 22 degrees Celsius. Now your right hand, which was in beaker A, what will it feel when it is in beaker C? It should feel colder than the left hand. And I'll pause the video and try question 3 before you move on. People in different countries, they use different temperature scale. People in Hong Kong use Celsius scale, but people in US, they use Fahrenheit scale. Talking about our body temperature, you may say it is 37 degrees Celsius, but you may also say it is 98.6 degrees Fahrenheit. So, how to do conversion between temperatures in degrees Celsius and that in Fahrenheit? Here are the formula that you may use. To change Fahrenheit temperature into Celsius temperature, you use this formula. To change Celsius temperature back to Fahrenheit temperature, you use another formula. Now there are 2 examples have been done for you. The first one, change 98.6 degrees Fahrenheit back to Celsius temperature. We use the first formula. So we subtract 32 from the Fahrenheit temperature and multiply with 5/9. So the results will be 37 degrees Celsius. The next example shows you how to change a temperature in degrees Celsius back to in degrees Fahrenheit. In that case, we multiply the temperature in degrees Celsius by 9/5, and then we add to the product 32. In this way, then we may find the results to be 98.6 degrees Fahrenheit. And I'll pause the video and try the checkpoint questions 6, 7, and 8. So here comes to the last part of today's lesson, calibrating a thermometer. So people now may start to ask the question, how it is made, how a thermometer is made. You may search the YouTube and then you may find this video. It's going to tell you how it is made. But basically, a thermometer is just a closed glass tube with both ends closed, and then there's a column of mercury trapped inside. So what we have to do is to make a scale. We have to calibrate the unmarked thermometer by giving it a scale. A thermometer that measures temperatures in degrees Celsius has a scale that spans from 0 degrees Celsius up to 100 degrees Celsius. The 0 degrees Celsius temperature refers to the temperature of ice pond or ice-water mixture. The 100 degrees Celsius temperature refers to the temperature of steam pond, boiling water. And these 2 temperatures are called fixed points of Celsius temperature scale. What we have to do is to mark the ice pond as 0 degrees Celsius, steam pond as 100 degrees Celsius, and then divide the separation between them into 100 divisions. And this is called calibration. An unmarked thermometer after calibration will be ready to measure temperature. So the diagram below tells you the steps. Number 1, you have to put the thermometer into ice-water mixture, which has a temperature of 0 degrees Celsius. So at that time, the length of the liquid column is L log. And then you will put it into boiling water. At that time, then the temperature is 100 degrees Celsius. So the length is marked as L100. The length of mercury column changes a lot from 0 degrees Celsius to 100 degrees Celsius. And from this length, then we may tell what temperature it is. The next step is to divide the length between 0 degrees Celsius and 100 degrees Celsius into 100 equal divisions. So you put a lot of little straight line here And in this way, then you produce the scale. The scale will be used for measuring temperature. So you finish the process of calibration. Some of you may ask why people are using Celsius temperature scale but not Fahrenheit temperature scale. The reason is because Anders Celsius was smart. Anders Celsius has chosen to easily reproduce fixed points. You can easily make 0 degrees Celsius at home by mixing water and ice. And by boiling water, you can produce 100 degrees Celsius. So he was smart. People can produce Celsius scale very easily. Well, you may also ask why when ice and water mix together, then the temperature must be 0 degrees Celsius. Well, the reason is simple because ice only exists at or below 0 degrees Celsius, while liquid water only exists between 0 degrees Celsius and 100 degrees Celsius. In this way, there's only one temperature, 0 degrees Celsius, that ice and water can both exist. Similarly, to have water and steam to exist at the same time, there is only one single temperature, that is 100 degrees Celsius. Well, from above, we know the length of liquid column at 100 degrees Celsius. We know the length of liquid column at 0 degrees Celsius. Then we should be able to tell the temperature X when the length of liquid column is Lx. Let me explain this very important formula using the picture on the next page. First of all, we should make the following multiplication. You change L2 to L100. You change L to Lx. You change L1 to L log. And this T, change it to X. And now we may find the slope of the graph. So here's the first triangle that can find the slope. Then I will draw this another one. And it can also find the slope. And so the slope can be given by L100 minus L log over 100, as it is at the bottom. It can also be given by Lx minus L log over x, as it is given by this formula. So, we may rearrange the formula and then we may have this result. In this way, by measuring the length of the mercury column, then we may find the unknown temperature X by using the formula. And now turn to the next page and take a look of checkpoint question 13. So let's read the question. It says that it is put into ice-water mixture. At that time it is 3.2 cm long for the liquid column. When it is in boiling water, the liquid column is 12.6 cm long. And now you are going to calculate how long the liquid column would be when it is in water of 50 degrees Celsius. So we may apply the formula and then we may write 50 equals to something like this, multiply with 100 degrees Celsius. So what they are? It should be the length when it is at ice-water mixture, 3.2 cm. Right? While L100 is 12.6. So here we go, that's the formula. And then in that way, then you may calculate Lx by using a calculator. Now you should pause the video and try checkpoint 10, 11, 12, and you may try also that method 2 of question 13. After you have finished all these exercises, you may check your answers on the back of the back cover. And before the end of the video, let me remind you to finish all the checkpoint questions up to question 13. And check your answers, and you may put question marks on those questions that you don't understand. And in this way, you should have done a very good job. And lastly, let me tell you that there will be a quiz at the beginning of the lesson. And I would like to remind you to bring a calculator and also a small single-line exercise book for the assignment questions. That's the end of the video. Thank you.